So we're picking up where we left off on this idea of solving quadratic equations by completing the square. You will remember that we said that our goal is to try and turn this into a trinomial squares pattern, which means a perfect square, and then the middle being 2 times the roots. So we're going to try this again with this next problem. You'll notice that when I try and solve this by completing the square, I have a first term that is a perfect square and a final term that is not a perfect square. I do know that the middle needs to be 2 times x times 9 to get that 18, which means that over here this must have been a 9 squared. Now, there's a couple different approaches that you can take to this problem. My personal suggestion is that you just go ahead and take that plus 74. We know it needs to be an 81, which means I need to add 7 to it. But remember, the property of equality says whatever you do on one side of the equation, you have to do to the other. So if I'm going to add a 7 to this left side of the equal sign, I also have to add the 7 on the right. That gives me x squared minus 18x plus 81 equals 7. This is a trinomial squares pattern that turns into x minus 9 squared equals 7. From here, I just take the square root of both sides. Don't forget, if you take the square root over here, you have to do the plus and minus sign. Squares and square roots undo each other. You get x minus 9 equals plus or minus radical 7. Add 9 to both sides. You get x equals 9 plus or minus radical 7. Here again, I'm going to suggest that you try this last one on your own and then watch the video to see if you did it correctly. I'm going to keep going for the sake of keeping the video short. I know this should be x squared minus 16x plus something. What I'm not sure about is what that plus something needs to be. But whatever it is, I'm also going to have to add it to the other side. This is a perfect square. This should be a perfect square. This middle should be 2 times x times whatever the root of that is. If I end up with a 16, I know this must be an 8. If that's an 8, that makes this a 64. Notice since I add a 64 to the left side, I also have to add it on the right. This is a trinomial squares pattern. This is x minus 8 squared equals, if I simplify this, I believe that is a 49. Square root both sides. Don't forget your plus minus sign. X minus 8 equals plus or minus 7. To get the x by itself, I add 8 to both sides. I get x equals 8 plus or minus 7. Now notice on these other problems, I was getting irrational numbers under the radical, or I was getting radicals that gave me irrational numbers. Over here, I got a rational number of 7. That means I do need to finish this problem. 8 plus 7 is 15. 8 minus 7 is 1. X could be either a 15 or a 1. I have 3 more examples here. You'll notice that on these 3, our leading coefficients are not 1. Up until now, I had 1x squared, 1x squared, and 1x squared. Now I have a 2x squared, a 2x squared, and a 3g squared. That's easy enough to take care of. You're going to want to make that leading coefficient into a 1 at the beginning. It is going to save you a whole lot of trouble. I'm going to do that by dividing both sides by 2. X squared plus 6x minus 7 equals 0. This is not a trinomial squares pattern. This is x squared. This is not a perfect square. And the middle should be 2 times x times whatever the root is. Do you know what this middle number should be? It's a 3. This ought to be a 3 squared, or a 9. I have to take this minus 7 and turn it into a 9. The way I'm going to do that is by adding, let's see, I have a negative 7, I want it to be a 9. How about 16? If I do it on one side, I have to do it on the other. This is now x squared plus 6x plus 9 equals 16. This is x plus 3 squared equals 16. I can square root both sides. Don't forget your plus minus sign. Squares and square roots undo each other. X plus 3 is plus or minus 4. Subtract 3 and I get x equals negative 3 plus or minus 4. Since that is a rational number, negative 3 plus 4 is 1. Negative 3 minus 4 is negative 7. Once again, if you get rid of that leading coefficient or change that leading coefficient to a 1, these are much, much easier to work with. Once again, I'm going to recommend you pause the video, try this one on your own, and then when you're finished, turn the video back on to check and see if you're doing it correctly. I'm going to do this a little more quickly this time. Divide away the 2. X squared plus 6x minus 18 equals 0. This is not a trinomial squares pattern. This is a perfect square. This is 2 times x times, we know that has to be a 3, which means this should be 3 squared. It's not 3 squared, it's an 18. 3 squared is a 9. If I want to take that minus 18 and turn it into a positive 9, I have to add 27. If I do it on one side, I have to do it on the other as well. This is x squared plus 6x plus 9 equals 27. Or x plus 3 squared equals 27. If I square root both sides, don't forget your plus minus sign, I get x plus 3 equals plus or minus, this is 3 radical 3. I put that in simplest radical form. If you're confused on what I did there, you need to go back and look up a video on simplest radical form. And then I'm going to subtract that 3 from both sides. Your final answer is negative 3 plus or minus 3 radical 3. And there you go. I have one more of these. One more time, I would suggest that you pause the video to work this out. Divide both sides by 3. We want that leading coefficient to be a 1. This is a g. The middle should be, I should say g squared. The middle should be 2 times g times 4, which means this last number should be a 4 squared or a 16. It is not a 4 squared or a 16. It is a 9. So I'm going to change this to a 16 by adding 7 to it. But if I do it on one side, I have to do it on the other. This is g squared minus 8g plus 16 equals 7. Or g minus 4 squared equals 7. I'm going to go ahead and square root both sides in the same step this time. Getting a little crazy in here. That gives me g minus 4 equals positive negative radical 7. And then I add 4 to both sides. G equals 4 plus or minus radical 7. Hopefully that will be sufficient for you in terms of what you need to do with completing the square. These can become more and more complex. Make sure you follow the same basic principles and you should be fine no matter how complex we make the problem.